Ever wondered, what is blockchain? This comprehensive guide breaks down blockchain technology simply, explaining how it works, its core concepts like decentralization and immutability, and its real-world applications beyond just crypto. Learn blockchain basics in an easy-to-understand way. Hey everyone, and welcome back to the channel. Have you ever heard terms like blockchain, decentralization, or distributed ledger, and felt a little lost? Maybe you associate it only with Bitcoin and confusing cryptocurrency charts. Well, you're not alone. For many, blockchain technology sounds complex, futuristic, and honestly, a bit intimidating. But what if I told you that at its core, blockchain is actually quite simple to understand? It's a revolutionary way to record information that's secure, transparent, and incredibly powerful. In this video, we're going to break down what is blockchain technology, step by step, explain how it works in plain English, and show you why it's so much more than just crypto. By the end of this, you'll have a solid grasp of this foundational technology. Ready? Let's dive in. Alright, let's start with the name itself, blockchain. It's quite literal. Imagine a digital ledger, like a giant shared spreadsheet. Instead of one big sheet, it's made up of individual blocks of information, and these blocks are chained together in a specific order. Each block contains a batch of data. For cryptocurrency, this would be transaction data, like Alice sent 5 Bitcoin to Bob. But it could be any kind of data: medical records, supply chain information, voting data. Crucially, each block also contains a timestamp, when it was created, and a unique digital fingerprint called a hash. Think of a hash like a digital signature for that block's data. And here's the clever part. Each new block added to the chain contains the hash of the previous block. This is what creates the chain. It's like a digital breadcrumb trail, making sure the blocks are linked sequentially and cannot be reordered or inserted. This is fundamental to how blockchain works. Now, imagine a traditional system, like your bank. All your transaction data is stored on their central servers. If that server goes down, or is hacked, or if the bank decides to change your records, they can. That's a centralized system. Blockchain, on the other hand, is decentralized. What does this mean? Instead of one central server, copies of the entire blockchain ledger are distributed across thousands, sometimes millions, of computers around the world. These computers are called nodes. When a new block of data is created, it's not added to one single server. Instead, it's added to everyone's copy of the ledger, after being verified by the network. There's no single company, government, or individual in control. This concept of decentralization in blockchain is revolutionary. This leads us to one of blockchain's most powerful features: immutability. Because each block contains the hash of the previous block, and copies of the ledger are distributed across so many nodes, it's virtually impossible to alter or delete past information. Think about it: if someone tried to change the data in an old block, that block's hash would change. Because the next block contains the old hash, the link would break. And since every node has a copy of the original, the network would immediately detect the discrepancy. For a fraudulent change to succeed, a hacker would need to change every single copy of the ledger simultaneously, across thousands of computers, and recalculate every subsequent block's hash, all faster than new blocks are being added. It's practically impossible. This makes blockchain records incredibly secure and trustworthy. This is why immutability is key to blockchain security. Another core principle is transparency. On a public blockchain, like Bitcoin or Ethereum, every transaction ever made is recorded and publicly viewable by anyone. You can see when money moved, how much, and to which address. Now, here's the caveat. While the transactions are transparent, the identities of the people making them are usually pseudonymous. You see a long string of numbers and letters, the wallet address, not Jane Smith. This offers a level of privacy while maintaining the integrity of the ledger. This public transparency means that fraud is difficult to hide, and audits become much simpler. It creates a system of trust based on cryptographic proof, rather than relying on a central authority. This is the essence of a distributed ledger technology, or DLT. We've touched on security, but let's deep dive a bit. Blockchain security relies on two main pillars: cryptography and consensus mechanisms. Cryptography is the science of secure communication. The hashes we talked about earlier are a form of cryptography. They encrypt data in such a way that it's nearly impossible to reverse engineer or tamper with. Every piece of data on the blockchain is cryptographically secured. Then there are consensus mechanisms. Since there's no central authority, how does everyone agree that a new block of data is legitimate and can be added to the chain? This is where consensus comes in. The most famous is proof of work, POW, used by Bitcoin. Computers, called miners, compete to solve complex mathematical puzzles. The first one to solve it gets to add the next block, and everyone else verifies their solution. It's energy-intensive but highly secure. Another popular one is proof of stake, polonium-2 sulfide, used by Ethereum. Instead of competing with computing power, participants stake their own cryptocurrency as collateral to validate transactions. The more they stake, the higher their chance of being chosen to add the next block. Both methods ensure that only valid transactions are added to the chain, making blockchain incredibly robust against attacks. This is crucial to understanding how blockchain security works. Let's put it all together with a simple example. How does a transaction happen on a blockchain? Initiation: Alice wants to send 5 units of a cryptocurrency to Bob. She creates a transaction using her digital wallet. This transaction is signed with her private cryptographic key, essentially her unique digital signature. Broadcast: this transaction is then broadcast to the entire blockchain network. Verification: nodes, miners or validators on the network receive the transaction. They verify its legitimacy, checking if Alice has enough funds, if her signature is valid, and if the transaction follows the network's rules. Block creation: once verified, the transaction is bundled with other pending transactions into a new block. Consensus: This new block then goes through the network's consensus mechanism, like proof of work or proof of stake. Once enough nodes agree it's valid, it's added to the existing blockchain. Confirmation: the transaction is now permanently recorded and irreversible. Bob's wallet reflects the received funds. This entire process, from Alice sending to Bob receiving, happens securely, transparently, and without any intermediary bank or clearinghouse. This is the essence of blockchain transactions. While Bitcoin and Ethereum are the most famous, not all blockchains are the same. There are primarily three types. Public blockchains. These are open to anyone. Anyone can join, read the ledger, send transactions, and participate in the consensus process, if they have the resources. Bitcoin and Ethereum are prime examples. They offer maximum decentralization and transparency. Private blockchains, also known as permissioned blockchains, these are controlled by a single entity. Participants need permission to join, read, or write to the ledger. Think of it like a private club. They offer higher transaction speeds and more privacy, but at the cost of decentralization. Often used by corporations for internal processes. Consortium blockchains, these are a hybrid. They are controlled by a pre-selected group of organizations, rather than a single entity. Imagine a group of banks using a shared blockchain for interbank settlements. They offer a balance between decentralization and control, often seen in specific industry applications. Understanding these types is key to grasping the full scope of blockchain technology applications. So, you might be thinking, this is cool for digital money, but what else can blockchain do? And this is where it gets really exciting. Blockchain's ability to create secure, immutable, and transparent records has applications far beyond just cryptocurrencies. Supply chain management, track goods from origin to consumer, ensuring authenticity and preventing counterfeiting. Imagine scanning a QR code on a product and seeing its entire journey, verified on a blockchain. Healthcare, securely store and share patient medical records between different providers, giving patients more control over their data while improving efficiency. Voting systems, create tamper-proof voting records, enhancing transparency and trust in elections. Intellectual property and royalties, artists and creators can register their work on a blockchain, proving ownership and ensuring fair royalty distribution. Digital identity, imagine a self-sovereign digital ID that you control, verified by blockchain, eliminating the need for countless usernames and passwords. The potential for blockchain applications to revolutionize industries is immense, creating a more trustworthy and efficient world.